Okay, let's look at the solution of this paper. Suppose z partially vary as square of k1 and partially vary inversely as k2. Now in this question, this is very tricky because usually we use the variation constant k1 and k2, but now it is used as a variable. Okay, so this question is very tricky. Therefore, we cannot use k1 and k2 as a variation constant anymore. We should use another. Usually, we can use a constant a times k1 square plus b over k2. Okay? In here, a, b are variation constant. k1 and k2 are variables. Okay? Now, look at the condition. When k1 equals 1, k2 equals 2, z equals 4. Therefore, you have first equation, that is 4 equals a times 1 square plus b over 2. And the second equation is k1 equals 2, k2 equals 4, z equals 9. So, 9 equals a times 2 square plus b over 4. And hence you can see that we have the equation 4 equals a plus b over 2 and 9 equals 4a plus b over 4. So the next step we can do is multiply 2 in the first equation, a equals 2a plus b, and second equation multiply by 4, so the 36 equals 16a plus b. Now do the subtraction of these two equations, then you will get 28 equals 14a, and hence a equals 2. When you get a equals 2, you can get b. b is equal to 4. Therefore, you can write down z equals 2 times k1 square plus 4 over k2. Now look at part B. If k is decreased by 20% and k2 is increased by 56.25%, find the percentage change of z. So let's see what's happened. Let z prime be the new value of z. And how does it come out? That is, the original k1 is decreased by 20%, so it has become 0.8 times k1. Okay, this means decreased by 20%. And k2 is increased by 56.25%, so 1.5625 k2. That's the new k2. Okay, and you can simplify this. 0.8 bracket square, that is 0.64 times 2 k1 square. Okay, plus in here, if you consider 1 over 1.5625, use the calculator to plug this, you also get 0.64. So you can take out 0.64 bracket 4 over k2. And hence you can see 0.64 is a common factor. Take out as a common factor, and inside the bracket there's 2k1 square plus 4 over k2. And here, this one is the original z. That means new z is equal to 0.64 times the old value of z. And what does that mean? 0.64 you can written as 1 minus 0.36. That means the new value of z is obtained by decrease original z by 36%. That's original z. You decrease it by 36%, you will get new value of z. Therefore, you can write down the final statement. Z is decreased by 36%. So that's finish of question number 1. And then let's go to question number 2. Okay, for question number 2, town A and town B are 72 km apart. The figure shows the graphs of the car P and car Q traveling on the same straight road between A and B during 8 a.m. to 10, okay? Car P travels at a constant speed. That means the speed of the car does not change, constant, okay? Car Q come to rest at 8:45. You can see there's a horizontal line. That means the car is taking a rest, okay? And both cars arrive to time B at 10 o'clock. A, find the distance of car P from town A at 8:45. Okay, so what does it find? Look at car P. You want to find the distance. That means you need to find the value of this one. Okay, that's distance D you want to find out. So how do we find out? First of all, you need to find the speed of the car P. Speed of car P that can be written as 72 km over 2 hours. That is 36 km per hour. And next, from 8 a.m. to 8:45, it takes 3/4 hours. Okay, so distance will equals to 36 times 45/60 total unit, kilometer. 36 times 45 divided by 60, so 27. That B is 27. At 8:45, car P is 27 km apart from A. So go to part B. At what time after 8 a.m. do two cars first met? This is the position of two cars first met. So when they met at the second time here, when would they met? And we assume it takes T hour, small letter T, after 8 a.m. they met. So you can see that at that time, car P traveled 39 kilometers already. So you can write in this way: the speed of car P, 36 times T. Speed multiplied with time equals to distance, 39. So you can get T, that is 13/12. And 13/12 hour, that means 1 hour and 5 minutes. Why? Because 13/12 can be written as 1 and 1/12. This is 1 hour. And how about 1/12? It can be written as 5/60. Okay, so that's 1 hour and 5 minutes. Therefore, they will meet at, okay, starting from 8 a.m. After 1 hour, that is 9 a.m. with 5 more minutes, so at 9:05. So part C, suppose the speed of car Q after the rest, this is here, is at most 66 km per hour. Find the longest possible resting time. That means, try to think, if car Q cannot take too much time to rest, okay, because the speed of the car Q in the second stage is just at most 66 km per hour, okay. So we can do in this way. Suppose it takes T, capital letter T, hour of the second journey of car Q from 39 to 72. So we can write in this way: 72 minus 39, that's the distance traveled by car Q in the second journey, over capital T, hour, should be at most 66. distance over time, that is speed, okay? So 33 less than or equal to 66 times capital T. So T is greater than 1 over 2. Like that is 1 over 2 hour. That means 30 minutes. Okay? That means here, at most, take 30 minutes. That is 9:30. Okay? And therefore, from 8:45 to 9:30, you can take at most 45 minutes to rest. Therefore, at most 45 minutes to take a rest. Okay, the resting time. So that's the end of question number 2. And go to question number 3. That's the question about the quadratic graph and transformation. Let f(x) be 2x squared minus 4kx minus 16x plus 2k squared plus 19k plus 32. K is a non-zero constant. And G is the graph of y equals fx. A, by using the method of completing square, express the coordinate of vertex of G1 in terms of K. So, very straightforward using method of completing square. But the difficulty is there's some constant unknown K. 2x squared plus 4kx okay, let me change the size of okay, this is better. Minus 16x plus 2k squared plus 19k plus 32. You can see that the x squared term, there's 2. Okay? The x term, okay, there are 2 of them. So you need to take the common factor x here. Okay? You need to take the common factor x here. Do not just handle negative 4kx. You need to consider negative 16x also. So we will do in this way. Take out the negative and then 4k plus 16 and then x. And then plus the constant term 2k squared plus 19k plus 32. And then you can take out the number 2 of the first 2 terms. These first 2 terms, you take out these 2. Take out the coefficient of x. So 2 bracket x squared minus 2k plus 8 and then x. And then close bracket. Because you need to add something and minus something in here. So leave some space here. And then plus 2k squared plus 19k plus 32. So what should we add here? In here, you can see that is the coefficient of x, 2k plus 8. First of all, you need to divide it by 2. 2k plus 8 divided by 2 whole term. That is become k plus 4. And here you should add k plus 4 bracket square. And then minus k plus 4 bracket square. You need to add this one and then minus this again. Why? Since after you add this one, the first 3 terms can become a perfect square. So next step, 2 bracket x squared minus 2k plus 8 bracket x plus k plus 4 all square. Multiply these 2 to the negative bracket k plus 4 square. Minus 2 bracket k plus 4 all square plus 2k square plus 19k plus 32. So next step, you can write it in this way. For the first one, this is a perfect square, x and then minus, drag it down, and here that is k plus 4 and then whole square. That's become the perfect square. And next you need to simplify something behind, okay? So that is negative 2 bracket. Simplify the square term first, that is k squared plus 8k. Do not miss this one, okay? Plus 16 plus 2k squared plus 19k plus 32. So fx can be written as x minus k plus 4 all square minus 2k squared plus 2k squared cancel. Negative 2 times 8k negative 16k. Negative 2 times negative 16, negative 32. So it just left 2 bracket x minus k plus 4 all square plus 3k. So you can see that the vertex is k plus 4, 3k. Here the x minus something, okay, the x coordinate of the vertex would be this one, whole k plus 4. And the constant at the end here, this is plus 3k. And go to B. Let G2 be the graph of y equals 4 minus fx. Now you should know the meaning of this one. From the graph y equals fx, you reflect along x-axis. That means upside down. That become y equals negative fx. Okay, that's the first transformation. And then you shift it 4 units upward. That would become y equals 4 minus fx. There are 2 transformations here. First one, you reflect the graph along the x-axis upside down, and then shift the intermediate image 4 units upward. So the point A is the vertex of G1, and point B would be the vertex of G2. So you can write down A and B directly. A, that is k plus 4, 3k, simple. And B, you can see that the x coordinate of point B is no change. But y coordinate, okay, first of all, upside down, so the y coordinate becomes negative, and then shift 4 units upward, plus 4. So the coordinate of B is k plus 4, comma, 4 minus 3k. You can observe that the x coordinates of the vertices are the same. O is the origin. The question asks you, could the orthocenter of triangle OAB be 4, 0? So let's draw the graph. Suppose there's an origin O. A, something like here, k plus 4, 3k, and B, something like here, okay? You can just sketch the graph. Some of you may think, oh, could k be negative? Of course, but I just sketched the graph to get some insight, okay? So here, that is a x-axis, and you know that AB is a vertical line because their x coordinates are the same, so it forms the right angle here. So you can see that the x-axis is one of the height of this triangle, and the second height of this triangle could be this one, okay? From A, draw a line perpendicular to OB. Alright, so this point 4, 0. The question asks you, is it possible? Is it possible? Okay, so you can see that suppose I let this point be H. Okay, you can observe that I want this point H as the orthocenter, means AH should be perpendicular to OB. And we check whether it is possible. Okay, since one of the height of this triangle is the x-axis already, so we just need to check. We want AH perpendicular to OB. Does it exist a value of k to satisfy this? So, once AH is perpendicular to OB, in a coordinate plane, if you want 2 straight lines perpendicular to each other, that means you want slope of AH times slope of OB equals -1. So check it. 3k minus 0 over k plus 4 minus 4. That is the slope of AH times the slope of OB. 4 minus 3k over k plus 4 equals -1. The first one, you will find that the slope is 3. Because k plus 4 minus 4, that's k. 3k over k, that's 3. K is non-zero, okay? So 4 minus 3k over k plus 4 equals negative 1 over 3. And hence, you can solve k. The value of k may not be so beautiful, maybe fraction, it doesn't matter. The key point is we can find such value of k. 12 minus 9k equals negative k minus 4. So you can find k equals 2. Therefore, when k equals 2, then the ortho center of triangle OAB would be 4, 0. Therefore, yes, it is possible. When k equals 2, then we can make it. Okay? If you cannot solve k, that means it could not be made. Okay? So that's the end of question number 3. And go to question number 4. That's the problem about a circle. Let C be a circle, x squared plus y squared plus minus 32x minus 24y plus 175 equal to 0, and be the center of circle. Part A, quite straightforward actually. Find the coordinate of n and radius of circle, respectively. Like usually, if the question gives you the equation of circle, you need to check their coefficient of x squared and coefficient of y squared should be 1. In here, okay, then you can apply the formula. The coordinate of center, that is negative d over 2, that is negative 32 over 2, and negative e over 2. And you get that is 16, 12. That is the center of the circle. How about the radius? That will be the square of the x coordinate of square plus square of the y coordinate of square minus the constant term here, f, 175. Then, so let's check. 16 square plus 12 square minus 175, and that is square root. That's 15. And B. Denote the origin as O. Prove that O lies outside C. How do you prove this? If the point is outside the circle C, that means the distance between the point O to the center with greater than radius. That you need to prove. Okay? So check the distance between O and N. That is 16 minus 0 all squared. For 12 minus 0 all squared. That is 20. You need to write down greater than 15. You must write down this one. Because the distance between O and N equal to 0, which is greater than the radius. Therefore, the point O lies outside the circle C. So, part C. M is a point on a circle such that M is the closest to M. What does that mean? Suppose there's a point O. There's a point N, center. ON, that is 20. And there's a circle with center N and radius 15. So here there is 5. And M is a point on this circle C, which is closest to M. So it must be this point. It must be this point. Joining ON and find the cutting point of this circle to this straight line ON. This point will be closest to O. Okay? And of course, some of you may think, how about that side? If you extend this line, if you extend this point will be farthest. Okay? This point would be closest. So how do we find the coordinate of this point? You can extract OMN here. O, 0, 0. M, unknown. N, 16, 12. And the length MN, that is the radius of circle, 15. OM would be 5. So you can use point of division. M that will be equals to 0 times 15 plus 16 times 5 over 20, comma. And then y coordinate 0 times 15 plus 12 times 5. 12 over 20. So M that is 4, 3. Okay? And part D. P is a moving point on C. Okay? Describe the geometric relationship between O, P, and N when the area of this triangle is the greatest. Okay, key point, greatest. Hence, find the corresponding perimeter, not area, okay, perimeter of this triangle. So let's draw the graph to explain this. Again, O, N, there's a circle, something like this. So, we know this one is M, okay, 5, 15. Now the point P is not fixed, it's moving, okay, it's moving. As you know, when the point P moves, the area of OPM will also move. So, we need to think, how do we find the area of triangle OPN? You can consider in this way. That's 1 over 2 times ON times MP times sine angle PNO, right? Okay, suppose point P is here. Suppose one of the possible point P, something like this, right? Then you can find the area, that is 1 over 2 times 20 times 15 times sine angle PNO. Okay? So finish the cancellation of number. That's 150 times sine angle PNO. So you can see that the area of this triangle PNO, it depends on the value of sine angle PNO. That means depend on this angle. So when will sine angle PNO be the greatest? Sine angle PNO equals 1 when angle PNO equals 90 degrees. We know that the sine function is the greatest at 1 when the angle equals 90 degrees. So that means when angle OMP or PNO is equal to 90 degrees, then the corresponding area of triangle PNO will be the greatest. Okay? So in this case, MP is perpendicular to ON. The question wants you to describe the geometric relationship. Okay? That means you need to use the terminology to describe that. Okay? Now you know that they are perpendicular. That means this is a right angled triangle. So perimeter will be 20 plus 15 plus square root 20 square plus 20 square. So what does that mean? 20, that is ON. 15, that is MP. And how about this one? That's OP. Okay, the hypotenuse of this triangle. So finally, you will get square, okay, 15 square plus 20 square, take square root. 25 plus 20 plus 15, 60. Final answer, 60. The corresponding perimeter would be 60. And that's the end of question number 4. So go to question number 5. And in this question, ABC is a triangular paper with angle A 52 degree. Okay, try to draw this. Angle C 68 degree. And you can find the rest of the angle actually, okay? 180 degree minus 52 degree minus 68 degree, that is 60 degree. AC 20 cm. D is a point on AC such that BD is an angle bisector of this angle ABC. So draw this line. Angle bisector 30 degree, 30 degree. And hence you can find the rest of the angle. That would be 30 plus 68, 98. And this one, 30 plus 52, 82. Part A, you need to find the length of AB and AD. So, in the big triangle, ABC, you can find AB. AB over sine 68 degree equals to 20 over sine 60 degree. Then you can find AB. (20) times sine 68 degree divided by sine 60 degree. This one, 21.41239392. And you need to correct to 360 to your final answer. And how do we find AD? Again, in the small triangle ABD, you can use sine rule again. AD over sine 30 degree equals to this one, AB, 21.41239392 divided by sine 98 degree. So you can find AD. This answer divided by sine 98 degree times sine 30 degree. So that's 10.811411289. For the final answer, you need to correct to 360, but in the calculation, you need to write down all numbers, okay? So that's finished part A. And part B. The triangular paper is folded along BD such that D is above the horizontal ground and the side AB and BC are still lying on the horizontal ground. So that's the case. When I fold it along the line BD, then D is above the horizontal ground and AB and BC are still lying on the horizontal ground, okay? That's B, that is A, okay? Now, AC is 15 cm now. Alright. Now the first question is, you need to find angle ABC on the horizontal ground. This one. Okay? So, let's check this one. Okay? B, A, C here. AC is now 15. AB, that is, you find in part A, 21.41239392. And BC, we didn't find it. Don't worry, we can use the figure in part A to find BC. After you find BC, then you can apply cosine rule to find this, I would say alpha, okay? So let's see. In this big triangle, original triangle ABC, BC over sine 52 degree will equals to 20 over sine 60 degree, alright? And hence you can find BC, that is 20 times sine 52 divided by sine 60. So the 18.19832883. Okay, then go to this one. You can apply cosine rule, right? Cosine alpha can be written as the sum of square of these two sides. And you can write out 4 decimal place. It doesn't matter. It's just the percent. But during the calculation in the calculator, you need to use all digits, okay? To prevent from the run-off error. The sum of square of two adjacent side of the angle, okay, minus the opposite side, and then over 2 times this one. So you can find alpha, okay. Cosine alpha, plug in this number. Like you can call this number by answer, but you need to plug in this number first, 21.412 something, right? Okay, so start a bracket, 21.41239392 square plus answer square, that means the 18.19 something, minus 15 square, close bracket, that's the numerator, divided by 2 times 21.41239392 times answer. You get this one, and then shift cosine. You get 43 degrees something. 43.56864.874 degree. Okay, that's B1. And then go to B2. Find the angle between the face ABD and the face BCD. So how do we do? Okay, what I'm doing is using the rubber sheet to draw the triangle like this. Draw the original one. This is quite useful for us to understand the situation. Okay, that's B, that is A, and that is C, and that's an angle bisector BD, right? So we draw this one, something like that. Okay, I can't show it. This point is D. Okay, the basic figure here. Now I fold this paper along BD and then place like this. Can you imagine that? Okay, AB line on the horizontal ground, and then BC line on the horizontal ground too. Okay, so I want to find the angle between these two faces. Okay, the angle between these two faces. So how do we do? First of all, we start from the definition. Okay, for these two faces, you can see the intersecting line, the common line would be this line. Okay, BD, the common line. So the next step we should do is starting from each line, starting each face, you draw the perpendicular line. From C, you draw the perpendicular line here. Okay, draw the perpendicular line here. And here, go further. We call these 2 points be M and N, respectively. And what you need to do is find this angle, MNC. The angle you need to find is MNC. Okay? So what you need to know is you need to know MC, MN, and CN on the ground. How do we find NC? Okay, you know BC, then you know the angle ABC inside the figure, inside the on the ground floor, right? So you need to find the length of BN also. That means you need to find MC, MN, BN. And hence, find CN. Finally, use the triangle MNC to find this angle inside here. Okay? So, let's see what we could do. Go to question number 5. Here, use the new one. Okay, in this figure, first of all, we find CM. I place it here. Okay. MC, that is equals to this line BC times sine 30 degree. Sine 30 degree, okay? 18.1983 double x3 times sine 30 degree. (18.1983 double x3 times sine 30). So that is this one. 9.099164415. And then we need to find BM, because after we find BM, we can find MN. Okay. So BM will equals to 18.19832 double x3 times cosine 30 degree. That is 15.7 something. 15.76021507. And next, you can, in the triangle BMN, you can find MN by using tangent. Okay. MN equals to this line, 15.76021507, right? Times tangent 30 degree. So this one times tangent 30 degree. Here that is again 9.099164415. And of course you can see that these two triangles are congruent. Actually these two are the same angle, common line, right angle. Okay, so this line BN actually it's predicted as 18.19 something. Okay, so let's see whether it is true. That is using 9.099164415 divided by sine 30. So that is 18.19832 double x3. So you can find all this length by using trigonometry or using the plane geometry. These two triangles are congruent actually. And now look at the triangle like this. B and C. And not this one. Okay, after the folding. Okay, there's the angle here, right? When you extend angle B and C and then A here, they will be something like this, right? So let's copy all the number we did before. For BC, that is 18.1983288. Okay, BN also 18.1893288. This angle we find in B1, that is 43.56864874 degree. The key point is we want to find NC. Okay, we want to find NC. So you can use cosine rule. You can use cosine law, okay, to find NC. And that is cosine, this NC square equals to 18.1983 bracket square plus 18.1983 bracket square minus 2 times 18.1983 times and other side 18.1983 cosine 43.5 degree. And you can write in this way, okay? But your presentation can take 4 decimal place, but in your calculator you should take all digits, okay? So this length square plus this length square minus 2 times this one times cosine this angle 43.56864874, and then take square root. That's 13.5 something. So NC, that is written as 13.50730178. Now you get this one, then you can consider the triangle MNC now. In this triangle, MNC, okay, NCM, you find NM already, that is 9.099164415. You can find MC 9.099164415, and then NC 13.50730178. So that is the isosceles triangle. Again, you can do it, join a perpendicular line here. These two would be theta, right? So these two sides will be the same. So 1 point, this one divided by 2, each side will be 6.7536508892. You can find sine theta. Sine theta, that is 6.7536508892 divided by 9.099164415. Then shift side, you will get theta, that is 47.92151953 degree. Okay, when you get this one, you need to multiply by 2. 2 theta to be 95.84303906 degree. Therefore, the required angle is 95.8 degree. Okay, that means the angle between these two faces. Okay, the angle inside here is a 95.8 degree. Okay, sometimes when you draw the picture and then try to use some graph paper or some rubber sheet to tear the paper like this, then you can get some information after you do some folding and write down some information. So you will find that in this case, these two triangles are congruent, then the calculation will become much more easier. Okay, so that's the end of this question, and that's the end of this paper. Thank you.